Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, I'll be tackling question number 5 from the media examination, which was written in the province of Eastern Cape in the year of 2024. Please note that, guys, the question has the question paper rather has 9 questions in total. And each and every one of those questions will have their own video. So please do expect a total number of 9 videos. And please, guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your media exam, your preliminary exam, and most importantly, your final examination. So please do take this seriously. Excuse me. We are told that a truck of mass 1,500 kilograms traveling at a constant speed of 20 meters per second to the west along a straight horizontal road collides with a stationary car of mass 900 kilograms and the two vehicles move together after collision. The collision lasted for 0.2 seconds. We must ignore the effects of air friction. Okay, if we can call this object A and that's object B, and secondly, you just choose our positive direction. Let's just take the direction of motion, which is the west direction, to be positive. Okay. The first question they want us to explain what is meant by the term isolated system. Okay, isolated system, guys, is a system whereby we have zero external forces. Are you together? We have zero external forces, or we can say is a system whereby all the forces that are present are at equilibrium. They are just balanced. Are you together? There are no external forces or non-conservative forces, and then or you can also say that is when the forces acting on the object are at equilibrium. Okay, states the principle of conservation of linear momentum in words. It simply states that in an isolated system, the total linear momentum is conserved. Are you together? Or you can say in a closed system, the total linear momentum is conserved. Are you together? And when momentum, guys, is conserved, believe me, it is conserved in both its magnitude and its direction. Are you together? It's conserved in both magnitude and direction. Okay, now they want us to calculate the speed of the vehicles after collision. Remember that, guys, we were told that the two vehicles, they moved together as one unit after collision. So for me to calculate over there, okay, yeah, let me just use the bottom. I'll simply say, since I'm dealing with a closed system, I can simply say the sum of the momentas before collision is just equal to the sum of the momentas after collision. Are you together? So it's momentum of body A. Remember that, guys, momentum is the product of both mass of an object and its velocity. The momentum of A initial plus the momentum of B initial. Since the two vehicles move together after collision, I'll simply find their combined momentum. So this will be the mass of body A plus the mass of body B multiplied by their final velocities after collision. Okay. Body A has a mass of 900 kilograms, but it was stationary, and hence the velocity is 0 meters per second. Body B has a mass of 1,500 and a speed of 20 meters per second to the left. Are you together? A constant speed of 20 meters per second to the left. I'll simply have 900 over there, which is the mass of body A. The mass of body B is just 1,500 multiplied by the final velocity. So that's 1,500 multiplied by 20. This will simply give me 30,000 being equal to 900 plus 1,500. That's 2,400 multiplied by the final velocity. I'll divide both sides by 2,400. So 30,000 divided by 2,400. And that will give me the final velocity of 12 meters, 12.5 rather, 12.5 meters per second. If they wanted the speed, I'll simply write this magnitude over there. But if they said they wanted the velocity, I was going to write both the magnitude and direction. So the speed of the vehicles after collision is just 12.5 meters per second. Okay. And then now they want us to calculate the net force exerted by the truck on the car. Remember that, guys, both objects will exert the same force on each other in opposite directions. Are you together? So you can find the net force exerted by the car on the truck, or find the net force exerted by the truck on the car. In this case, they want the force exerted on the car. Yeah? So I'll simply say that I know that according to the momentum, to the F-net momentum equation, I know that the product, to the impulse momentum equation rather, impulse is also equal to the change in momentum. That means F-net will be the change in momentum, which is mass multiplied by the change in velocity all over the change in time. So the mass of the truck is just 900. The final velocity, the truck was moving at 12.5 meters per second, but it was initially stationary, and the amount of time it took for the collision to occur is just 0.2 seconds. That's just 0.2 seconds. You'll obviously say 900 multiplied by 12.5 minus 0 all over 0.2 seconds. Excuse me. This will give me the resultant force of 56,250 newtons. So since it's a positive force, that means the truck is imposing a force on the car to move towards the left or towards its western position. Are you together? So that's 556,250 newtons west. Okay, and then now we are being asked, is the collision elastic or inelastic? The collision will be elastic if and only if the kinetic energy is conserved. Okay, so we need to find the sum of kinetic energies before collision and also find the sum of kinetic energies after collision. If both of these are equal, we can therefore conclude that the collision was elastic. Okay, let's do so. That's half mv squared for object A plus half mv squared for object B. Object A initially was stationary. Are you together? So its velocity is 0. So when the velocity is 0, kinetic energy is also equal to 0 joules. But the truck was moving at a constant speed of 20 meters per second. So the kinetic energy before collision is just 1 over 2 multiplied by 1,500 multiplied by 20 squared. That's basically 300,000 joules. Okay, now let's go and find the kinetic energy after collision. They both move at the same speed, right? Or as a unit. So I just need to add their masses. Mass of body A plus mass of body B times the velocity squared. That's 900 plus 1,500 multiplied by 12.5 squared 1 over 2 900 plus 1500 multiplied by 12.5 squared. This gives me 187,500 joules. So I can conclude that the collision is inelastic. Why? The kinetic energy is not conserved. Is not conserved. Are you together? If the kinetic energy was conserved, that means the collision was going to be elastic. Okay, and then now you're told that delicate equipment is usually packaged using bubble wraps. Bubble wraps for safety of the equipment. Explain how this process keeps the equipment. Ne? Okay. Bubble wraps have a softer package. Are you together? If ever maybe we are transporting delicate equipment using a truck, and maybe let's say a truck gets into a car accident, the bubble wraps are there to protect the delicate equipment. Yeah. So what the bubble wraps will do, that's F net is equal to the change in momentum all over the change in time. Yeah. The bubble wraps will just increase the contact time. Are you together? And then when the contact time is increased, that simply means the force exerted on the delicate equipment will decrease. Are you together? And hence the delicate equipment will be less damaged. The bubble wraps will increase the time of contact, or the time of contact. Are you together? And since we know that since F net is inversely proportional to the time of contact, we can therefore conclude that net force exerted on the equipment will decrease. Are you together? And hence our equipment will be less damaged. And hence the equipment will be less damaged. That's how, guys, we're supposed to tackle that question over there. So just stay tuned and wait for more videos. Thank you.